All right. Greetings to you all. It's a beautiful Saturday morning once again, and I would like to welcome everybody to today's webinar. My name is Fidelis Obaniyi, and I'm the host for today's event. This webinar is organized by Abuja R User Group, a local community of R user in the capital city of Nigeria, Abuja. And for today's event, our topic is communicating data insights with visuals using ggplot. So quickly, I would also like to appreciate the founder and coordinator of this local community in person of Bilikisu Umi Aderinto. Thank you, ma'am. Without wasting much of our time, it is my honor to introduce our guest speaker for today's webinar in person of Oluwafemi Oyedele. Oluwafemi Oyedele is a Okay. Oluwafemi Oyedele is a research fellow with IITA, and he earned a master's degree in agricultural metrology from the University of Ibadan. He's a passionate R user. He uses R for his job and personal or private work as well. So it is my honor to welcome Oluwafemi Oyedele to today's webinar. And I believe he's very ready to take us through this process. Mr. Oluwafemi Oyedele, can you hear me, sir?
Yes, I can hear you. Thank you very much for the brief introduction. Let me just quickly share my, I think you need to give me permission so that I can share
okay. I'll do that right away.
Okay, good morning, everybody. First, once again, I would like to thank the host, the organizer, the Abuja R User Group for giving me this opportunity once again to present this topic, which is titled Communicating Data Insights with Visuals using ggplot2. Before I proceed, I would like to just give a brief rundown again of myself. As the moderator rightly say, I earned my MSc in agrometrology. I'm also a crop simulation modeler. I'm also a member of the R for Data Science online learning community. I also participate in the Tidy Tuesday project that is hosted by the House Studio. Also, I am also passionate about reading. I read a lot of books. You can connect with me either on LinkedIn, on Twitter, I think on GitHub, or my personal website that I developed using the Blockdown package. So over for today, I would like to look at the agenda, what we'll be doing today. I'll be taking the introduction to the grammar of graphics, which is a ggplot2. We'll be looking at the different layers that is in ggplot2. The focus of this talk is about the 20% that is always useful, the 80% of the time. But more in-depth coverage is available in the resources I will mention later. My goal is always to make you excited about this great package called ggplot2. At the end of the talk, I will always entertain questions, but all the materials for this talk, they are available in this GitHub repository. But for the slides in which I am sharing, let me quickly drop the link in the chat where you can get, for you to access the slides that I'll be using. I think if you click on this link, I think it will, the slide I am presenting right now, you will be able to see so that you can follow along. And also, because I am also following on the discussions in the chats, so if there is any area in which anything that is not clear, feel free to stop me at any point and ask questions. So I will entertain your question. So the package we'll be using today is the ggplot2. And as we all know, ggplot2 is a system for declaratively creating graphics based on the grammar of graphics. Based on the grammar of graphics, you provide data, you tell ggplot how to map variables to aesthetics, what graphical primitives to use, and ggplot is going to take care of the details for you. So in order for you to install the package in which we are using, the package is, if you are interested in installing the stable version that is on CRAN, so you have to run this line, install.packages, then you specify the package, which is ggplot2. But if you are interested in installing the development version that is on GitHub, then that means you need to install the DevTools. Okay, then from there, within the DevTools, here I'm just calling the DevTools from my namespace. DevTools install _GitHub. Then I specify the name of the GitHub repo, which is tidyverse, then the name of the package, which we want to install, which is ggplot2. Then I have to call the library in order for me to get access to the functions in which we'll be using. So I say library ggplot2, and here I use the annotation package to just create an annotation. The recent version of the package is version 3.3.5. That is the most, but whatever version you are good to go. So for this talk, we'll be looking at the grammar of graphics, but we can't talk about the grammar of graphics without making reference to this book that was written by Leland Wilkinson, that is titled the book as The Grammar of Graphics. This book was first published in 1999. So the whole idea about the book is that it talks about the theoretical deconstruction of data graphics, okay, whereby it breaks down all the components of graphics into the different layers. And this book now forms the foundation of many graphic applications, in which the ggplot2 is one of them, because ggplot2 is one of the core packages in the tidyverse. So the GG in ggplot2 is just like an implementation of what we call the grammar of graphics. So it's just like an implementer of the grammar of graphics. Here I present the decomposition of graphics into its constituents. Here at the lower end here, we always start with the data. With data, we specify the mapping, the statistics. So, and at the top end here is where we have the theme. So in my next slides, I'll be picking on each of these layers. Then we go in deeper to know what these layers actually what they stand for. So yeah, at the very bottom end here, in every visualization, we always start with the data, because without data, there is no visualization that we want to create. So, and ggplot is always expecting that our data set in which we want to use to do our visualization, the data set, it has to be a tidy data, because the author of this package at the Wickham, he do publish a paper where it describes in detail what is a tidy data. That is a data in which every column is a variable, every row is going to be our observation, and every cell is going to be a value which gives us the table. So in order for you to work with the ggplot2 package, it's always expecting that your data set is tidy. But if your data set is not tidy, there are tools out there within the tidyverse in which the dplyr and the tidyr, we can use it in tidy in this data set and make sure the data is in the tidy format. But I think that is not the agenda for today, because the agenda for today is about the visualization aspect. So the next aspect in this graphics is always the mapping. So in this mapping there, what we are doing is that we are actually linking variables that are in a data set to visual properties of the geometry. So maybe we can have a particular data set in which we have maybe 4 columns. Let me give an instance that we have 4 columns. Example is the iris data set that we are all familiar with, that has sepal length, sepal width, petal length, and the species, in which the species is always the category. So I can say map the sepal length to the x-axis, okay? Then I map the sepal width to the y-axis. Then I can say, okay, I have this particular variable called species. Can you color it by the species? Can you use shape to distinguish between the 3 species? Then the alpha in which I put here, the alpha is to control the transparency in the plot, and the value always range between 0 and 1. Then the size. If you want to use size, we can just say size is equals to species. Then it's going to distinguish those species based on the different size. But the size is always very good when we have values that are variables that are continuous. So the next slides, because when I first started using this package, when I started learning then I always talk about data mapping geometry. When it comes to statistics, I don't care about, because within each geometry, there is always a default statistics. So I said here, the statistics help us transform the input variable to displayed values, because within each geometry, there is always a default statistics in which the package, they have already arranged it. So even though you do not specify which statistics, the package is going to know from the values, it's going to use a default stats, and everything it will render the visuals using the geometry. So I say even tidy data may need some transformation. The statistics is linked to the geometry, because every geometry will have its own default statistics. That is why I say in the last bullet, it is implicit in many plot types, but it can be done prior to what? Plotting, because in every plot type, this stats is always set. It's always set, is already fixed already. So we don't need to do anything. Then the next point there is the scales. Yeah, the scales help us to control the mapping from the data to what? Aesthetics. It helps us to control mapping from data to aesthetics. Scales also provide the tools that lets you interpret the plot, like the axis, the legends. So scales are automatically generated in ggplot and can be customized using, we can use within the scale. There are several arguments in which we can use within the scale. Within the scale, we can simply transform maybe the x-axis, we can transform the y-axis, we can specify there are a lot of arguments. Maybe when we are going to the actual demo in the subsequent slides, then I will show how we can play with this. So the last, this other slide here is talking about the geometry. So the geometry helps us to interpret the aesthetics as graphical representation, because it's the geometry that actually does the main job that will display the visualization. Because we have done the data, we map those data into our aesthetic mapping. Then this data set has been scaled, the statistics has been computed by default. So what is going to render that plot? So the geometry will now pick all these values that have been scaled down and now render the final plot. So if you now specify that geom bar, that is what you want, is going to give you the bar plot, which by default is using the start count. So when we say you need the geom points, by default, you know it's going to be scatter plots. So the default there is always start identities, because don't do anything, just pick this data the way it is, then you render it. Then if you are using the box plot, it's going to be stat underscore box plot. Then the density, then is density, the histogram here is going to count based on the bin. So it's going to count based on the bin and just render the plot. So like now, maybe we have some variables. The facet is very useful when it comes to visualization. It helps us to divide data into panels using 1 or 2 groups. It also allows you to look at smaller subsets of the data sets. So it's very useful in visualization and facets. By default in ggplot, the facet is always facet_null. That means don't do anything. So that is the default setting in which the package they have already set in ggplot. But we also have facet_wrap. Within the facet_wrap, we can specify the number of rows or the number of columns. Then we can also set both axes either on a free scale. We can say scale free X, scale free Y, or scale free. So there are several arguments within the facets. Then the last, but not second to the last here, is the coordinate system, because all this, what interprets what we are seeing on paper is actually the coordinate system. I say the coordinate system maps the position of object onto the plane of the plots. It is also the physical mapping of a static to the paper, because this actually controls what we render, what we are going to see in our final paper. Then coordinate system affect all position variables simultaneously and differ from scales in that they change the appearance of the geometric objects. The coordinate systems control how the axis and grid lines are also drawn on the plot. So within the coordinate system, there are some other customization in which we can do, because within the coordinate system, we can also zoom into specific areas on the plot, because if we are doing that within the scale, if we specify values that fall outside the range in which we specify within the scale, by default, ggplot is going to replace those values as NA, and is going to complain that so rows has been dropped from your data set. So when you want to do the actual zooming, to me, I always prefer doing, if I want to zoom into specific areas, maybe in the y-axis or the x-axis of the plot, I always prefer to zoom within the coordinate system, because the default coordinate system for all visualization in ggplot is always the Cartesian coordinate system. That is always the default coordinate system is the Cartesian coordinate system. But we also have other coordinate system in which I will show when I am talking on each of this layer. So the last,
Hello, sorry.
Okay.
Sorry to cut you in. There's a comment in the chat here that kind of they want you to slow down. Okay.
Okay.
Yeah.
Let me see. I can't see. Okay, there are some message. There is a comment. Okay. There is no problem. So, but I hope where I am so far, you can follow me. Or are there any issue in which I can just go back? Anything that is not clear? Sorry. Hello.
Hello. Okay. Ola, I believe he's talking with you.
Yes,
so
yes,
okay.
Thank you.
Okay.
We are together.
Okay, thank you so much.
Okay, so that maybe I would slow down, because while I was speaking, I have around 70 slides. I'm trying to meet up with the time. Okay, so maybe I will go slow. So the coordinates are the team, which is the last layer I'm trying to explain. The team helps us to control the overall look. What control the overall look of the plots is the team, which is very important. It spans every part of the graphic that is not linked to the data, because the team is always linked to the mapping, because we use the team to customize what we have mapped in our plots. So the team gives you control over things like the fonts, the ticks, the panels, the panel strips, the background. Maybe, for example, that you have developed a visualization using ggplot2, you want to submit this to a journal, and each of these journal, they have their own templates that these are our specification for every figure. So it is within the team that you do all those customization at the end, because this is always at the end after you have done all your visualization. It's within the team that you do all your customization. Though for you to generate any graphics using ggplot2, there are three these important layers that are very important: the data, the mapping, and the geometry. So if you do not specify anything for the other 5 layers, ggplot2 will just assume, okay, there is no problem. It's going to use the default, what has been set by default. That is what ggplot is going to use, and is going to render the plots. So now let's go into the actual demo, where, because I'll be using the Zaringan slides, because all the codes, I've rendered all the codes here. You can see the output so that we can all interact. Then at the end, I think I have shared the link for the slide. I also share the link to the GitHub repo. If you want to get all the source code, you can access it there. So at the beginning of every visualization in ggplot, we always start with the data. And I said earlier on that the data sets, it needs to be tidy. This is an example of a tidy data set. I just say head on the iris data set. I said I need to access just the first 2 rows so that we can see what is there. It contains sepal length, sepal width, petal width, and the species. Then I just said I just want to see what this contain the first 2 rows. So this is the first 2 rows. So the first thing in ggplot, the first thing, as I said earlier, is always starting with this gg function. So when we have loaded the library, we say ggplot, then the first argument is always the data, where I specify the data is equals to iris. So when I execute this in my RStudio, so I run these codes. So at the plot window, this is what you are going to see. You are going to see this gray background. So at that moment, you have only done you have only executed just 1 layer, but the next stage is asked for us to do the static mapping. And the beauty of this is that if you are familiar with the tidyverse, you must have been aware with the pipe. So in ggplot, the pipe in ggplot2, when they developed this package, by that time, the pipe has not been discovered. So the pipe in ggplot2 is like a plus sign. So we are using that plus sign to add layers upon layers. So that is how we will start from data. We go to the mapping. From the mapping, we go to the statistics, the scale, the geometry, so that in that order. So when you run that, you are going to see this. So in the next stage, now, I still use the same data set, data iris. Within the data set, I put a comma, I do my mapping. Mapping, AES here stands for aesthetics. Know that I want to do aesthetic mapping. And I'll say within this iris data set, there is a column called sepal length. Map that column in the x-axis. Then within this same iris data set, there is a column called sepal width. Then I said, place that column in the y-axis. Then there is a column called species. Then I say, color it by the species. Then there's a column called species also. I say, show the different species using different shape. Then I put a comma there and I'll say alpha 0.5. You can see my alpha, I'm not putting it within the aesthetics. I am doing it outside the aesthetics. So anything you put outside the aesthetics, it will not appear in the legends if the guides is to be displayed. So now, if you execute these codes, it's going to give us this output. We are going to have this gray background because the default theme in ggplot is always a gray theme gray. So we are going to see, okay, we have dropped this, mapped this to the Y, we have mapped this to the X. So now, the next thing for us to see what the actual visualization is for us to specify the geometry. So when we now go in the geometry, so by default, there are around 53 geometry in the ggplot, but there are some other extension packages in which when we install those packages, they will add more geometry to ggplot. So I use this function from the utils package, apropos, then I use within quotes, then I put geometry underscore to check all the geometry that is in the ggplot. So it shows me that these are all the geometry in which we can get from ggplot. Okay, so now still using that same data set, okay, I will add a new layer to it. I just add a plus sign and I say geometry is the underscore point. So when I say geometry underscore points, that is when ggplot now renders the plots, now shows anything. Here, I did not specify anything for the scales. I did not specify anything for the statistics. So by default, it's going to use the default scales and also the default statistics, which is always stat identity. That means don't do anything, just pick this value that is coming from the iris data set and render the plot. So that is the default statistics in which ggplot uses. And there we have these outputs from. So yeah, I said variable that is not linked to the data sets. So if you do this, because when I always start, at times I make this mistake. I did not have any color. I did not have any column that is named blue in the iris data set. And I'll say color equals blue plus geom points. This is what we are going to have. It's going to drop this legend here, color blue. So what ggplot is doing is that it's going to look at all the rows. That is, all the rows in your data set is going to be scaled down, and it's going to just drop this random value, this random color as red, and now drop. Anytime you see red, you know that color is blue in the data sets. So that is what, so the best approach, if you have any variables that you want to map that is not linked to your data set, it's always good we do it outside our aesthetic, which is what I did here. It's always good we do it outside the aesthetics. In that case, it will not drop any legend here. It will just render it just the way you want it to be. It's always good we do it outside the aesthetics, not within the aesthetics. We go outside of the aesthetics and we specify that. So as I said earlier on, this is the default. This is the default in ggplot. We always specify data, mapping, and geometry is very important in any visualization using ggplot2. Data, mapping, so if you do not specify anything here, so ggplot is just going to render the visualization using the default value that come with the package. So yeah, I'm using another data set. This data set is called Faithful. The Faithful data set is from the ggplot2 package, because all the data I am using for the demo, they are all, if you have ggplot2 installed and your R is in your machine, you have access to the data set. So because I make everything to be simple based on what we are doing, so that we will not have to be specifying parts. So now I say data is faithful. Here I changed the order of the mapping. I am now doing my mapping within my geometry, not within the data again. So that is why in ggplot or in R for a general, they are different way in which you can do things. So now I have changed the order. Instead of me to map, initially I was doing my mapping within the data, but now I am doing the actual mapping within the geometry. Here I said X, I map X to be eruption, Y, I map Y to be weighting, then color is equals to eruption where eruptions is less than 3. So it's going to drop this. We can see where eruption is less than 3, which are this region. So where eruption is greater than 3, you can see these are the regions. So we can use within the plot, we can check for specific condition in our visualization when we are doing our exploratory data analysis, which is very important. So here is an examples of bar plots. Here I'm using the iris data sets. Then I am also doing the mapping within the geometry. I map X for the species. Then I fill the bar by the different species. Then here, data equals null. When I did not specify anything, I specify data equals null, means that ggplot is going to grab data from here, from the iris. So I specify the data here null. Then the width of the bar, I say it should be 0.7. So when I run this line in my console, this is going to be the resultant outputs. So what by default for the geom bar, okay, by default is using start count. So it's going to count how many setosa we had having is 50, how many species is 50, how many virginica it is 50. So but the default statistics for bar plot is always start count. So it's going to count. But if you want to change it, you need to specify X and Y, then you say start identity. That means don't do anything, but just render this visualization using my data sets. So yeah, because at times I have this type of error. Okay. At times I have this type of error. I run into this at times whereby I say data is iris, then I do my mapping, X is species, Y is sepal length, then I fill by the species. Then I say plus geom bar, then I say width of the bar is 0.9, then ggplot will complain. Start counts can only have only X or Y aesthetics. So why is that? Because geom bar, the default statistics in which they have set is always start count. There you just need to specify your X, then it's going to do the counting. So for me to overcome this, I need to now specify start. I put a comma here within the width, I put a comma here, and I can now say start is equals to within quotes identity. Then if you run that line, this is the resultant output. For me to put a comma and now specify start equals identity. So when I now run that line, this is the final output. If I execute the codes, it's going to give us this output. Am I too fast, or is there any issue at course? I am also following the chat. I think there.
Yeah, it's okay. It's okay.
Okay. So for this also, I said this shows I'm using a different approach here. I'm using another data set from ggplot, which is a diamond data set. Then I am doing the mapping. Here I map color to be X. I map price on the Y-axis. Then I fill this bar by the cuts. When I fill by the cuts, so it's going to place these guides here. Then I have a plus sign here. I specify geom call. Then position is equals to fill. Okay, when I say position equals to fill, it's going to count the proportion. Now it's going to be based on the proportion of each cut, and it's going to arrange them based on those proportions. But if you are interested in dodging this bar, we can say position is equals to what? Dodge. Then it's going to dodge them. But in this case, I want to see the proportion. But it's now showing from 0, this is around 100%. Okay. So here I did with the same data set, but I did something different. Here. I introduced another approach where I said start equals summary. I introduced a new approach here. Here I said data, I have my diamond data sets. I did my mapping, which is the X. I say reorder the color by the price. Then the function in which I want to reorder by is the mean. But in the forecast, I can also do this within the forecast package, the FCT reorder within the forecast can also do this. Then here I say reorder, the reorder is from the base R, color by the price, then function equals the mean. Then the Y-axis, I said it should be the price, which is what we are having there. Then I said I fill the bars by the cuts, plus geom bar. Then the statistics I want to compute is summary, okay? Then the function in which I am getting from this summary, I said do the mean, give me the mean. So each of this should be the mean for each value. Then I just relabel because this reorder is going to affect the label of the X-axis. So that is why I have to say X lab diamond color. So when I execute the codes, so this is the resultant outputs. Using this gray background, though the customization, that one will always be the last thing. We'll see that at the end. Here I did another one. This is for the box plots. Maybe you are interested in seeing the distribution between how a categorical variable relates to a specific numeric variable that is continuous. Here, I use the iris data sets that I map X to be species, Y to be sepal width, Then I fill the box by the species. Then the geometry, I said geometry should be box plots plus geom jitter. You can also use geom points. Why I use geom jitter is that I want to see the spread of these points. I want to see how these points are dispersed based on this. But the alternative approach is, if you don't want this, because in every box plot, I need to know in each group, what is the sample size. If you do not want this approach, you can just place the sample size at the bottom after setosa. I can just put a line break. I say, yeah, we have the number of sample here is 50. The number of sample here is 50. The number of sample here is, but if you can't do that, you just better you jitter the points. So that we can see the number of sample that falls in each group. Then I put a plus sign here, add a new layers for the stats. I specify stat summary. Within this stat summary, I say function is for the mean. Then the geometry should be points. Then the shape 23. This is the shape for the mean, which is like a goat sign that I'm putting. Then I fill that by color white. Then I say the size should be 2.5. So when I render the codes, the resultant output is going to be this. Yes, I think the box plot, yes, there is no whiskers. I am coming to that. I think the subsequent slides, I have whiskers there. And I also have another slide where I put the notch. I am coming to that. I think the subsequent slide, I have the whiskers. This is just a demo. Remember, I said ggplot we have different layers, the data, the mapping, and there was a reason why I did not put the whiskers. So the subsequent slides, I think I have whiskers. They have a slide that cover that. So here, the histogram. Okay, so I said data equals iris, then plus geom sign is histogram. Then I did my mapping within the geometry. I said let X be sepal length, then I fill it by the species. So by default, the default bin width for every visualization for histogram in R, this one has been set to 30, but you can change it to any bin width, to any bin, number of bin. The number of bin is always set by default is 30 for any visualization in R, but you can change it. If you are interested in maybe 20, you can just say bins equals within this histogram, I can just put a comma here, bin equals 20, comma again, bin width equals maybe 0.5. So you can render it, but the default bins is always 30 in ggplot. So yeah, I said the default, okay, this is just what I just said now. The default bin width is always, is the default behavior of geom histogram is equivalent to the following. Okay, so this is the default for the geom histogram. This is what is going on when you said in the previous slide I just showed. So the data is iris. Within the aesthetics, I say X is sepal length, which is this. Then Y value, though we are not seeing this Y value in the previous slide, but this is the trick that is going on. So ggplot is going to use this function after the statistics for all the counts that belongs to different bin has been computed. It's going to say after the start, drop the counts in the y-axis, then fill it by the species. So when you execute that code, this is the same plot we saw here. This is what ggplot is doing, so that you have to understand the grammar. So when you execute that code, so it's going to give you, this is the same plot I just showed in the last slide. So now, maybe you want to visualize like a time series. You have some certain variables that are continuous, that from this is a date. You map it to the x-axis, then you map this to the y-axis. Then here I am using a new function. Here I'm using a new function. I had a plus sign there. I said stats_summary. It's a new function in ggplot, because before now, what I was doing is that I would do all my data wrangling then I now pipe it to ggplot. But with this new function, I don't need to do all that. I do all my wrangling on the plots. I don't need to use dplyr. So I just read in my data set. I just filter out what I want to use. I pass it straight to the visualization. With the start summary, I can do a lot of computation in my visual. So this simple one, I just say the function I am using is the mean. Then the geometry, I specify the geometry should be line. So it just place this, it just shows us the trend, how they increase exponentially over time, how the unemployment rate is increasing over time. This is a violin plot. It's similar to the box plots. This one is similar to what we saw earlier in the box plot. Here we map the species to the x-axis, the petal length to the y-axis. Then I fill it by the species. Then I just specify the geometry should be violin. So it just gives us this, and we can see that we can see the distribution, the shape, which shows actually the distribution based on the data sets we are feeding in. This shows the statistics. Here I said I will not go in details here because you will still get the slides. So here I still use the functions from the Apple Pros to just check all the pattern that start with start underscore in this package. We can see all the statistics that we have in ggplot. That the stats are being for the histogram that we stored earlier, the start density for the density plots, the start box plot, which is for the box plots, the start count, which is for the bar plots. So there are a lot of statistics like start SF, like the simple feature if you are into geospatial analysis, start summary. So now to the Whiskers. So these are the Whiskers. These are the Whiskers. So I know the reason why I did not show the Whiskers then, because I want to pick each layer. Then I talk on based on each layer that we have. So now I said data, we have the iris, okay? Then I did my mapping. I said X, I want to reorder the species by the sepal length. Then here I just specify the function. You should use the median, but if you want to use the mean, you can put the mean there. Then I put a comma. I said the Y should be the sepal width, which is what we have here. Then I fill it by the different species. Then from there I said plus. I use a plus sign because I am adding a new layer. Stats box plots is the statistics for box plot. Then the geometry, I said it should be the error bar. So that is going to place these error bars in the box plots. The top and the bottom are the Whiskers. Then I put a plus sign there. I said geometry should be box plots. Then I specified the notch of the box plot. I said it should be true. And the notch helps us to check the level of uncertainty between the median. Okay. Then I said plus geom jitter. I want to jitter the points. But if you do not want to jitter the points, you can say geom points. It's going to just place those points there. But I prefer the geom jitter to show how the points are spread, because if you check so many journals, they normally jitter the points. So I say geom jitter. Then I had a plus sign because I am adding a new layer to the ggplot. I said start underscore summary. Then the function, it should be the mean. Then the geometry there, I specify the geom should be points. Okay. The shape should be 23, which is for this white shape. Then I fill it by white. Size equals 25. Since I have already tampered with the x-axis label here, I have to label it using the XLab to relabel it to put the species here. So when I run this, if I highlight this code and press my Control Enter or Command Enter, if you're on Mac and you execute this code there, this is the output you are going to get. Okay. So here, I was like explaining what is happening when you have a scatter plot, what is actually happening. So we need to know the default stats for the scatter plot. Remember earlier on I said it's always stats identity. So I have my data sets here. I said data is equals to iris. I had a new layer, which is stats underscore identity. That means don't do anything, just pick the values from this data set and give me my plot. Then the mapping there within the start identity, I said X should be the weight, Y should be the miles per gallon. Then if I should execute, highlight this code and Control Enter if you are on Windows, or Command Enter. So this is the actual outputs. You are going to get these actual outputs. Okay. So now for the bar plots that we saw earlier on, remember I said the bar plots, the transformation is always start count. So it's counting like I have cuts in the x-axis. So it's going to count in this variable, how many cuts do we have? So it's going to count the total number of cuts, the total number of goods, very good, premium, and also it's going to count all this value and it's going to map this value on the y-axis. So we are the height of the bar is going to be based on those counts, based on those counts. Then here I said that you can find out which stats each job uses by looking at the default values of the stats argument of the help page. That is, if you run a question mark right now on your console, if you put a question mark, if you have loaded the ggplot library ggplot2, then you say question mark, you put a question mark and you type job underscore bar. So you are going to see the documentation of this function and you'll see the various arguments and you'll see that the default stat is always count. The default stat of bar is always count. So like now, maybe you want to visualize some data sets. You want the error bars to show the level of precisions around the mean. Okay, so this is the approach. Okay, here I say the data is diamond. Then within my mapping, in my mapping, I say X is the cost, Y is the price. Then I add a new layer called stat summary. Remember, I say stat summary. We also have stat summary too, but I am stat summary. Okay, then the geometry. I said equals to bar within string, within quotes. Then the function, I said it should be the mean because I want to have the height of this bar represent the mean for each cut, the mean value for each cut. Then I put a comma. Alpha there is to control the transparency of the plot. I said 0. It ranges between 0 to I think 1. Here I said 0.6, so it should be a little bit transparent. Then I added plus sign there. I put another argument, start summary, a new layer to overwrite this other layer. Here I said geometry is equals to error bar because I need these error bars. Okay, then the font of data. So which function am I applying to the data? It should be mean plus or minus standard error. But if you are interested in standard deviation, it should be mean underscore SD. It's going to be mean underscore SD. Then the width of the bar is 0.2. So the width, I need the width of this bar. I set it to 0.2. So it's going to be 0.2 divided by the total number of bars. So for us to determine that width. Then I did another argument. I add a new layer here where I specified stat underscore summary. Then I said geometry should be points. Then the function should be mean. So if I should highlight these codes, I Control Enter or Command Enter. If you are Mac and you execute it, this is the output. Because how I did this is that I make everything simple so that as I am presenting, you can also follow along. You can also, so that you see that the codes I am displaying, they are working. So now, in this case, maybe we have a scatter plot, but I want to show the mean value for each data point, for each group. I want to know where the mean value fall within each group. I still use the same stat summary function again, which is a very powerful function. I say ggplot, I pass in my data set, which is MPG in this case, plus sign to add a new layer. I say geom_jitter because I want to spread those points. I want to spread the points. Then within the mapping, I say aesthetics, X is class. I say X should be class. Then Y should be highway miles per gallons. Then the width of the bar, I said it should be 0.2. Then I add a plus sign to add a new layer to the plot. Then I said stats_summary. Then the mapping here, I did a new mapping, aesthetics, X class, Y should be highways. Then the function, I apply the function because I need the mean is equals to mean. Then the geometry is still the points. I need point, I color it as red. So we can see that, we can see that each of these points, these red dotted points, they actually show the mean for each class. We can see where the mean value fall within each class, which is a very good approach for you to see. So yeah, maybe you do a visualization, you do a scatter plot, you want to put a best fit line. Here I place the X value, the X value there on the log 10 scale. I place it on the log 10, I transform it on the visuals, because before now, maybe we would do all this transformation in Excel, but now the power of R, you can do everything in ggplot. On the plots, we can do a lot of transformation. We can do the square roots, can do the log. So they are all, here I just place the X on a log 10 scale. So the Y is displacements. So the geometry there, I say it should be points. Then alpha, which controls the transparency, is 0.4. The size, I say let it be 2, plus sign. Then I now add a new geom called geom_smooth, which will add this smooth the best fit line and also the confidence interval. These are but if you are not interested in the confidence interval, we can say standard, you can put a comma here and put standard error equals false. But the good thing with this geom_smooth function is that if I did not specify the method equals LM, which is linear model, so the geom_smooth function is going to look at our data set and is going to think for the best algorithms that fits this data set. So that is what, in some cases, majority of the cases, it might put just a polynomial model that best suits your data. It's going to fit, it's based on the best model that suits your data. Then, but the confidence interval, if you are not interested, you can just put a comma here and say standard SE within quotes, SE equals false. So when you put that SE equals false, you will just see just this, the line, then the standard error will not be there. For alternative approach, then I think I was using the geom AB line can also, but in that case, you need to specify the intercept, you need to specify the slope. But I do prefer this function, it's a good function. So this was showing like a points range. Maybe you want to see the range between from the minimum to maximum. Though I hardly see this type of visualization, but it's also good. It's also good visual when you want to explore. Here, I use a different pipe. I use a different pipe, which is from the base R. This greater than sign is still similar. It's still the same thing like us using percentage greater than percentage, the pipe that we know in the tidyverse. Since I am using the ggplot, I just want to stick to ggplot. I don't want to go use the pipe. That is why if you check all my slides, I try to stick to the package in which I am using. So I say iris, then I pipe the iris data sets to ggplot. Then I say within the aesthetics, I said let X be species, let Y be sepal length. Then I add a plus sign to add a new layer. Then I said stats summary. Then I said geometry should be points range. Then the font.max, I should say it should be the maximum data points, which will be here. Font.minimum should place the minimum data points there. Then the function should be mean. So these dots here we are seeing in the plot, they represent the mean for each of the species, which also good. So now the scales. Okay, here I said the scales in ggplot control the mapping from data to aesthetics. I think I have covered this already when I was showing those diagrams. So here also, if you are interested in seeing all the scales that we have in ggplot, I also use these functions. They are proposed. You can see here we have around 122 scales. These are a lot of functions that is available in ggplot. I always do the head to check the first 50, which is what we have here. We have scale alpha, scale color depth, scale color brewer. So, but though I'm going to pick some of these scales, then we work on them. So here, I said modifying the scales, okay? So this is a simple plot in which we have already seen before. Here I said data, I used the MPG data set. I did my aesthetic mapping. I added my geometry. Then within my geometry, I said the color should be by the class, which is what we are seeing here. Sorry, which is what we are seeing here. So this is what actually happened when we do this. If we from here, if we do this, this is what the default, what is going on ggplot. If you just say ggplot data is this geometry, this color, this is what ggplot is doing. It's saying scale X continuous. It's not going to put anything there. So ggplot is going to think for the range that best fits your data set. Then scale Y continuous. ggplot is also going, the algorithm is going to think what is the range, the data points that best suits this. So ggplot is going to fit everything there. Then scale color discrete. So it's going to just put a random discrete color here. It's going to put this color here, the random color. So everything is by default. Remember I said the three important layers in ggplot is always data, the geometry, and the mapping. Those three, they are very important. The other ones, if you did not say anything, ggplot is just going to use the default values. So this is what is happening within the scale. So here now, I just place the x-axis on a log10 scale. In these other ones, I place the x-axis on a log10 scale. Okay, which is the same plot we have seen already. Here, I just add a new layer, scale color brewer. And within the scale color brewer, the first argument is always the name. I say name is equals to class. I can use it to rename the title here. Okay, I can use it to rename. I just rename this from lowercase. I just say, let it be class. Then palette, I say set one. There are other palettes because this R color, this palette is coming from the R color brewer. But if you have ggplot, when you specify palettes, it will just pick that color. We also have DAP2. There are several palettes that are available in the R color brewer package, but there are also type arguments, the type argument where you can say either you want it to be sequential, divergent, but this, in this example, I just say palette should be set one. So when you highlight this code and run, so this is the output you are going to get. So here I did a different thing. Here I just changed the type argument to be qual. Qual means qualitative. So, but they are also, if I say type equals sequential or spectral, is going to change the ordering, going to change the color. But there are some other additional color palettes in which we can use the R color brewer is also a good one. There are several other color palettes. I think the color picker is also a good package in which I think I use at times when I want to pick a good color that will fit my visuals. Here, what is here? I said modifying color for the bar plots. I did the same thing here. I said the name is species. I just renamed this. Then the palettes, I use a different palettes. I said DAP2. So when I highlight this code and I run, we are going to get this neat palette. I think I use this a lot. Yeah, I place the y-axis on a log10 scale, which is what, wait, I place the y-axis, scale y continuous, then I just say transformation I want to apply to this scale. I said it should be on the log 10, then scale x continuous, then I specify breaks. For my x scale, I say it should break after 3, 5, and 6. So when I light and run, ggplot will just, maybe if you have your own default breaks that you want to specify, you can specify your own breaks. So it's also a good way in ggplot. So when you highlight the codes and you execute it, it's going to give you this output. Here, how to supply. Okay, this one here I use, instead of me to use scale color, Brewa, I use scale color manual. If you are using this, you are going to supply your own manual scale to the plots. Then I say the name should be class, then the values. Within I create a character vector for all the colors should be red, blue, green, cyan, gray 50, pink, and black. So in that order, ggplot is going to arrange those colors. So what is doing all this is our scale, because scale is going to what? Pick all this value, transform all this, and make sure this, after they have been transformed, this scale is now going to pick all this static value, make sure that it's converted into values in which the computer will understand, the computer can interpret. So the resultant output is now going to be this background. Okay, yeah, I was telling you so many possibilities within the scale, because there is also another function called the guides, which is also a great function that which is like an extension for the scales. So within the scales, I can customize everything that is happening in the y-axis. The axis labels, I can modify it. The axis title, I can modify it. The x-axis, I can do all sorts of modification within the scales. And also within the scales, I can modify everything you are seeing in the legends. I can customize everything you are seeing in the legends within the scale. Because the power of ggplot is that ggplot is a package that is well documented. They have good documentation. Because if you just put a question mark in your computer and just say, browse VigNet ggplot2, you will see the details of the package. I think it's a package that has a good documentation. Here I was specifying, within the scale, I specify the breaks for the x-axis. I say it should break the year, should be every 10 years, there should be a break. So we have a data point here for me to get from here, this point to this point is 10 years interval. From this point to this point is going to be 10 years interval. So I can just specify the breaks so that it will make the plots to be clear and also readable. Here also is a new approach. This is another approach that I did here. I passed in my data sets. I did my mapping. I had a plus sign for the jump bar. Then I said scale field brewer. Then the name, I said the name should be based on the species. Then the palettes, I use the DAP2. Then I put a plus sign to add a new layer. I say scale X, it should be the discrete. Then the X, the name value, the names there, I said it should be species, which is there. Then the labels, then I now label the X-axis. I now say the labels within quotes, I say Setosa, I put / and N. It's like a line break. This is a line break in HTML is a line break. I specify a line break. Okay. Though I can also do this with the GT text where I can write pure HTML, but I do not want where I'll just say BR-BR. So I write pure HTML to specify that break. But since I was working with the ggplots, I make everything should just be based on ggplots. So here I specify the line break. I say the number equals 50. I put a comma there. I have versicolor here. I also did a line break such that we can see that Setosa, we can see the number of samples that we use is 50. Versicolor, we know that the number of samples that fall in this group is also 50. This other one is also 50. So if you highlight and run, this will be the resultant output. So now the coordinate system, because we have been talking about data, geometry, scale, statistics, the coordinate system, this is actually what is going to render our plot in the paper. So by default, earlier on I said the default coordinate system is always the Cartesian coordinate system. But if you want to go into geospatial analysis, they have the chord map function. This is, then you can convert, but we can move from one coordinate system to another. Within the chord, we can flip. Chord flip is when we want to flip between the X and the Y axis. We want to flip, maybe the text that is in the X axis is not readable. We can say, okay, I use the chord flip. I will now take the X axis, drop it in the Y axis, bring the Y axis, drop in the, we can just flip the coordinates, which is what I did here in the chord flip. Then chord trans is like I want to do a transformation within those coordinate system. So, but the default coordinate system in ggplot is a Cartesian coordinate system, as I said earlier, but you can move from a Cartesian coordinate system to another coordinate system. But the difference is that it's going to change the shape, the look of the plots, because you can see when we specify chord polar, you can see the outputs. Here is an example data set I was trying to, within the chord Cartesian, I want to zoom in on the y-axis, where I say my zoom level should start from 0 to what, 40. So when I copy this and I execute, this is what we are going to see. But if I use the, within the scale argument, as I said earlier on, if I am to do this within the scale argument, any value that fall outside this range. So by default, ggplot, the package is going to convert that value to NA, is going, and ggplot is going to complain. So rows been with missing data has been dropped. It's going to complain that so rows in your visualization has been dropped. So it's always advisable if you are to zoom into your visualization, it should be within the chord Cartesian, which is very good. So yeah, now, remember from this plot, if you look at the x-axis, you can see the spaces from within the x and the y-axis. We have spaces beneath. So for us to remove that white spaces there is what I was trying to do here. Within the chord Cartesian, I also specify the expansion limits should be 0 to 40. Then I say the expand is equals to expansion. Then I say multiply by mod value. I do not want to multiply by anything. So I put 0 to turn it off. Then add value. I don't want to add any value to the top. But if you are interested in adding any value to the top, you can just say add is equals to C. You create a character vector. Then within that, you now specify the value you want to add at the top. But in this case, I'm not adding any value. So I say add is equals to 0. So if I do highlight the codes and I execute, so it's going to bring, give us these outputs that we are seeing. Then those spaces, it will remove those spaces there. So like faceting, as I said earlier, the default in every visualization in ggplot is always this. It's always set to facet null. Facet is very useful in your graphics. Maybe you want to split, you have some certain categorical variable, you want to split those values based on into different panels, so that we can see the pattern that is going on in the different panel. So ggplot has this, what we call the facets underscore grid and the facets underscore wrap. And within this facets, you can specify the number of rows, the number of columns. You can specify the scales. Either you want to free the x-axis. If you say scales within quote, you put free, it's going to free both axes. Then if you say scale is equals to free y, means that you are freeing the y-axis. It's going to be set on a free scale. Then the x-axis is going to be fixed. So let's see what is there. This is an example. Data for facet wrap. I just do a tilde tilde, which is like an anonymous function. I say class, that I want to split the class into different panels. Here I said the number of rows should be 2, which is what we are seeing, 2 rows. Okay, so when you highlight the codes and you run, this is the output we are going to get. And within this facet wrap, we can say scales. We can set either the X on a free scale by default. Those scales, they are set on a fixed scale by default. So, but if you are interested, you can say free. You can free those axis scale. So this is an example of a facet grid where we arrange those plots based on rows and columns. So it's going to create a panel of grids where this other one is going to be based on the drive. This other panel is going to be based on the 3 cylinders that we have. So when we highlight the codes and we run, ggplot is going to give us these outputs. This is the resultant outputs that we are going to get. So here, for the team, for me to assess, I also use this function from the utils package to assess all the teams that are available in ggplot. Okay, because by default, this is a default team. Okay, there is a question on the chat. Let me go to, so what is the difference between facets, grids, and facet wrap? Okay, like facet wrap is that we want to split the plots into different panels based on the number of rows, based on the rows, because you can see in the facet grid. In the facet grid, we will create a panel of grids based on rows and column. It will arrange. You can. This is a wrap. We cannot have any other panel at the left. Yeah, this is for facet wrap. It's just going to facet is going to split everything based on this. I will just specify number of rows. If I also specify number of columns, it's going to arrange them based on those facets. But in the facets grid, I can split it based on 2 different categorical variables. But in the facet wrap, it's going to just be based on 1 value, because if you use 2, the visualization is not going to be more informative. So it's always good we use facet grid when we want to split our plot based on 2 categorical variables. So this, the top here is for the first categorical variable, the drive will take this top panels. Then this other one will take this other panels. This other one will take this other panels. So it's just going to arrange the plot. So within that, we can see what is going on within each of those panels. We can see what is going on within each of those panels. Okay, so here, as I was saying, the default team in ggplot is always this team, the gray team. But there are several other teams. We can use the black and white team. We can choose to use the classic team, but this one is based on your own choice. But to me, I love either the classic team or the test team test, or I just write my code and I modify everything. If I don't want to program very much, I just go straight to use a team test, or I use a team classic or the team minimum. So, but at the beginning of your visualization, you can set a default team. That is to override this team gray, in which any graph in which you are producing, they are all going to follow that team. That is just say team set team underscore test. If you do that at the beginning of your script, know that any visualization you are creating in R, they are going to obey based on that team that you have just set. So you can see that I use the team get function, the length team gets to get all the team. We have 93 different teams because this is, remember, this is the last stage of the visualization, because you need to customize our visuals based on specific standard, because each journal, they will have their own standard, which they expect your visuals to look like. So I just check, we have around 93 teams for us to modify. So I now say team gets, and then I do the add function. I do the head to access just the first row, which is for the line. You can see the default arguments there. Color is a character. The color is always black. The size, the default size in which the set in the package is numeric 0.5. The line type, numeric 1, but if you do team get $, you put the specific argument, you access all the function. You can now see the default, what ggplot, what they have set, but you can overwrite, you can always overwrite it. So here, within the team get, I just get the default team for the title of the plot, but you can do it for other parameters that you get from the team get. I just access the title of the plot. You can see that the default, the family, that is the font family, is always set to null. The face is always set to null. The color is always set to null. The size, relative should be numeric 1.2. That is 1.2 times what you will set. The age just is always set, horizontal justification is set to 0. Vertical justification is 1. These are all the default theme in ggplot. But when you are working, you can always customize all this. You can always overwrite it and you supply your own theme. So here, I will say we can use theme if we want to tweak the display of an existing theme. The theme layer refers to all non-data ink, as I said earlier, such as the title, the labels, the fonts, the background, grid lines, and the legend. Any text elements in the theme can be modified with element text function. Okay, any line, we can modify it with the element line function. Any rectangle, we can modify it with the elements rect. Theming defines the feel and look of your final visualizations. And it's something you will normally defer to the final polishing of the plot. There are around 40 unique themes. So they can be roughly grouped into 5. I group them into what? 5 categories: the plot, the axis, the legends, the panels, and also the facets that we can customize. So as I said earlier, if you have this plot title, plots, the text, the legend title, all these elements in the first column, you'll just say equal, within the theme, you just say equals elements underscore text. Elements underscore text is the resultant arguments you put there. All this, the second columns in the middle, though I will show a brief demo where I use all this function. All this, the resultant arguments must always be elements underscore line. So if there is any rectangle there, should be elements underscore rect. All these arguments, we can customize it with the elements rect function. So like here, I did the facet wrap by the year to split this data based on the 2 different years. Okay, then I set the theme. I set the theme to be minimal, which is what we are seeing there. I just set the theme to be minimal. So when I execute the codes, so it's going to give us this output. So here now, the theme customization that I was saying earlier on now. I did a new thing here. I used the MPG data sets, the geometry. Within the geometry, I said I did my aesthetic mapping. I said let Y be the class. Okay. Then I did facet wrap to split it by the 2 different years. Then I add a plus sign to add a new layer for the labs. Okay. The title of the plots, this title here, I said it should be number of car models per class. Then the caption, which is what we have here, I put this 12 golf. Okay. The x-axis, I set it to null. Okay. The y-axis, I set it to null. But if you want to put any value there, you just put it within string. Okay. Then I use scale x continuous because the x value, they are on a continuous scale. So that is why I use scale x continuous. Then I say expansion should be between 0. Then the maximum limit, I said, I don't know. I just put NA there. So ggplot will understand, it will look for it. Then plus, I add a new layer theme minimal, which is the minimal theme I use. Then I add a new argument plus theme to customize this plot. Then for the text, all the text, remember I say all the text should be equals to what? Elements underscore text. Then the family, I set the family of the text should be Avena next condensed, but if you prefer, you can, for majority of the time, I always set it to serif, the serif, okay, or the mono, but I prefer the serif. Then I put a comma there, strip dot text, okay, for each of this strip of the panel. So I said all the text should have, all the text should be bold. So it's going to bold this panel. It's going to bold the year 1999 and 2008. Case just should be 0. So it's going to place it there at the top. Then the plot caption, which is always elements underscore text. Then the face, I italicize the caption. I italicize the caption. This I italicize plot caption, which is for this guy here. I italicize it. Then I put a comma there, panel.grid.measure, which I set it to elements line. That is panel.grid.measure, the measure grid line. The measure grid line, I set it to elements line. Then the color, I set it to white, which is what we are seeing here. Then the size, I put the size to be 0.5. I put a comma there, panel.grid.minor, the minor grid line, I turn it off. Anytime you say element blank, that means you don't need that theme, you have off that theme entirely. I said element blank. So this element blank, remove this guy from the plot. Then I say comma, panel.grid.measure.y for the Y grid line, okay? I also set it to elements underscore blank. I don't need it. Then the panel on top, I set it to each panel should be on top each other. I set it to true. Then I highlight this code, Control Enter. Then the output will be this. Okay. So now we have done the whole thing about the visualizations. We have seen a little demo about customization of the plots. The next stage for us to do now is for us to save our plots. Okay, and for us to do that, we use this ggsave function. So the first argument will be the name of the plot. So I say plot.name.png. So I want to save this plot as a PNG. Then for the plots, I say last underscore plots. Okay. This last underscore plot, but if you have any object in your environment that you use to save that plot, you can just say plot equals P1. Maybe you save the plot as P1, you can just say plot equals P1. But if you say last underscore plots, I will understand that the last plot that is in your outputs, so is going to know that you want to save that plot. Then I specify the width, the height, the units, and the DPI, which has the resolution of the plot, 450. But if you have specific location that you want these outputs to go, you can put a comma here, then you specify the path in which you want to save that plot. But in this case, I did not specify any path. So when I highlight this and I run, it would just save the plots. So as I said earlier on, I will be mentioning some resources. If you look at these slides, there are all these links. If you click on any of this link, it will take you to all these resources. You will be able to, you have access to all these resources. The elegant grammar of graphics for the data visualization. If you want to learn more further on what we have discussed today, we can also visit the ggplot2 website, which is also a good website where you see all the function, the R for data science online book, the advanced R, useful R Studio cheat sheets. You can look at this fundamental of data visualization and also storytelling with data. I think all this, they are already embedded in the link I sent earlier on. Okay, so I would like to thank the people who made this presentation successful. First, I would like to thank the Abuja users, our user group for organizer for giving me the opportunity to do these presentations. I also like to thank the UEZ for developing good tools that such as a Kenneth Aldo. He has developed a lot of tools that makes the open source software to really improve. I would also like to thank Thomas, he's a software engineer also at our studio, for giving a wonderful talk that is plotting anything with ggplot2, which also inspired my own talk. And all these slides in which I am sharing were all created with the Zaringan R package. So I would like to take question. I think I am through that.
All right. Awesome, awesome, awesome. Thank you so much, Mr. Oluwafemi Oyedele, for that wonderful presentation. So it's time now for question and answer. If you have a question, you could just raise your hand or you use the chat box. Question, question, question. Do we have any question? I hope we all can hear me.
Yeah.
Okay, okay.
Yes, we can. Although I don't have a question, I just want to thank Mr. Femi Oyedele for very nice presentation. Yeah, and we look forward to more of that. Yeah, thank you.
Thank you.
Thank you so much. Any other comment? All right, in the absence of none, Madam Bilikisu, I don't know if you have any question or comment, ma.
Okay. I don't, no question at all. Just
Yes.
we would want to thank Mr. Femi Oyedele. So, but I think you can do that.
All right, all right. Okay. Thank you so much, Mr. Oyedele, for that wonderful presentation.
Thank you.
And it's such an educative one, an informative one at that. So on behalf of Abuja R User Group, we want to appreciate you for being our guest speaker today and delivering such a wonderful presentation. And also would like to thank all the participants. So we really appreciate you for joining us, and we also look forward to having you subsequently. Especially, I would also like to thank Mrs. Bilikisu Umeaderinto for being a great leader, the founder and coordinator of this Abuja R User Group. I really appreciate you, madam. So once again, my name is Fidelis Obani, and it's a pleasure having you people on today's meeting. Thank you so much.
Okay. Thank you all. Thank you.
Okay, sorry, before we round up. So you'll round up again, Fidelis. So I want to give a shout out to Toye for being so early today. So I want to really thank him. He's been here with us for so long, I think. So thank you so much. And I will use this opportunity also to say thank you very much on behalf of the Abuja R User Group. And thank you so much, Fidelis, for being a wonderful coordinator of the webinar today. You did great. So thank you, everybody. Thank you so much for attending. So I'll hand over to you, Fidelis. Thank you.
All right. Thank you once again, madam. Mr. Oyedele, we would like to appreciate you for this wonderful presentation. And we also want to let you know that subsequently, we also want to have you again, maybe on some other topics, because we have a lot of topics to discuss around, especially about our programming language. So also for Mr. Mr. Are Akin. You've been a wonderful participant. Thank you so much for attending today's webinar as well. And I also want to appreciate everybody for joining us, and we hope to see you in subsequent webinars. Thank you so much, and God bless.
Thank you.
Bye.